Greetings. Our group now will present our assignment, which involve the image transformation and analysis. Our group is consists of 4 members. This is our group members. So let's start thing first off with introduction. The goal of this assignment is to able to modify an original image. So as you can see, as we know, the modification of image can lead to many different purposes such as reconstruct image. For example, image filtering, and another one, applying visual effects to image. For example, blurring or censoring images. And lastly, edge detection onto the image, so that setting boundaries for machine to recognize the edges onto the image. So corresponding to these 3 modification purposes, we demonstrate them in 3 different tasks, and those tasks are: task number 1, to visualize an image in the frequency domain, modify it, then reconstruct it. Task 2, apply blur effect on your original image, observe the output image when the standard deviation changes. And lastly, task 3, apply edge detection to the edges of the original image. Observe output image when standard deviation changes. So as you can see, the picture on the left this picture will be used throughout this task to act as our original image, and we will modify them corresponding to the task. And our task will be conducted using MATLAB application.
Hello everyone. Today I'll be presenting an image processing script using MATLAB. Our goal is to visualize an image in the frequency domain, modify it, and then reconstruct it. We start by loading our original image named team.jpg. This is the picture of our group members. To simplify the processing, we convert the image to grayscale. Next, we calculate the Fourier transform of the grayscale image. Let's look at the center spectrum of the Fourier transform. Next, we apply a log transform to enhance the visualization. Lastly, we reconstruct the image from the modified Fourier transform. In summary, we have explored the frequency domain of our image using Fourier transform. This process allows us to visualize and modify the image in a unique way.
Hi and Assalamualaikum. My name is Syazira binti Imam Asa'ad, and I will show you task number 2. Here is the coding of task number 2. I will explain line by line. For line 2, this line read an image file on the specific part and assign it to the variable which is original image. In line 6 until line 8, it shows us the original image. In line 11, this line creates an array named standard deviation value that containing 4 standard deviation value, which is 1, 5, 10 and 20. You can modify this array to include different values. For line 14, this line starts a loop that iterates through each standard deviation value in the standard deviation value array. In line 16, this line applies Gaussian blur to the original image using the ungaussified function with the specific standard deviation. The result is stored in the variable blur image. In line 19 until line 21, this line creates a new figure for displaying the result. This line also displays the current blur image in the specific subplot. Next, I will show you the output of 4 different standard deviation value. For this slide, we can see that it shows the output of standard deviation value of 1 and 5. For the next slide, we can see that the output of standard deviation 10 and 20. That's all from me. Thank you.
Assalamualaikum and hi. My name is Intan Raihanah binti Othman. I will show you how to solve the task 3. The question asks us to apply edge detection to the edge of the original image and also output image when the standard deviation value change. First thing first, we can see clearly throughout the code program. The original image is loaded in the image GPG. If it's the color image we're going to use for the task, we'll convert it to grayscale. Next, a loop iterates through the different standard deviation value sigmas as the question asks for. Then for each sigma, the script applies Gaussian blur using Immuscufit in the MATLAB, and then applies the selection of Gaussian edge detection using edge function with allow method. Last but not least, we will run the program and output result will be appear. The resulting image are displayed in 2x2 subplot for easy comparison. That's all from me. Thank you.
As for conclusion of this assignment, and what the assignment is, throughout the task we conduct, we can observe that image can be altered and modified to a certain degree depending on the method we use. One of the method is fast Fourier transform, which able to construct an image from the frequency domain. And then the other method is Gaussian kernel, can result in blur in image. Throughout the task, we can see that the different value of standard deviation make the image more blurry. And lastly, the last method is the Laplacian of Gaussian kernel. This method can be used to detect edges within the picture. So the difference in standard deviation value causes the detection and preciseness of the edge detection differ. So the higher the deviation value, the more precise the edges detect throughout the image. So that is all from me. That is all from us. Thank you very much.